What is electromagnet? Today we are going to focus on electromagnet. What is it and how it is made? Okay, electromagnet can be defined like this. It is a temporary magnet. Electromagnet, we can say what? It is a temporary magnet. It is a temporary magnet made by using electricity. And actually, it is a piece of iron, we can say ferromagnetic substance also, a piece of iron placed inside a current carrying solenoid. Look at this may be the definition of electromagnet. This is temporary magnet, one point we have to remember, and it is made by using electricity, second focus point. And actually this much definition is enough for lower class, but we have to be a little more clear about this. Actually, it is a piece of iron placed inside a current carrying solenoid. At this place we have to be clear about solenoid first. Now question comes, what is solenoid? Now I want to focus on solenoid. What is it? Solenoid consists of a long conductor wire wound closely on a cylindrical form. We can say a little more about this like this. The turns of the wire are uniformly spaced. Looking at this only, we cannot understand so clearly. Solenoid consists of a long conductor wire wound closely on a cylindrical form. What it mean? It's like this. If a long conductor wire is wound like this way, look at this is a solenoid. This is called solenoid. Now what is told here? A solenoid consists of a long conductor wire wound closely on a cylindrical form. The turns of the wire are uniformly spaced. These turns are uniformly spaced. The space between two neighboring turns are more or less equal from one end to the another end. Now we have to go back to the definition. What I told, the definition of electromagnet may be like this. It is actually electromagnet is a piece of iron placed inside a current carrying solenoid. Now I want to show you the diagram of electromagnet. If you are told to draw a diagram to show the method of making electromagnet, then you can draw this way. Let's say this is a piece of iron, and this piece of iron is if wound with insulated copper wire. to make you more clear, I'm using different color. This way, if it is wound with insulated copper wire, this way, then this iron is inside a solenoid. It's very simple. Iron is inside the solenoid, and two terminals are, if connected to the positive terminal and negative terminal of cell. This is positive terminal, this is negative, this is positive, this is negative. If two cells are used, we can write this positive and negative. And if current is passed this way, then this piece of iron becomes a magnet. This is solenoid. This iron piece, a piece of iron, this is, you can say, electromagnet. Now, electromagnet is a piece of iron placed inside a current carrying solenoid. Now, when current passes through this solenoid, actually it never passes through the iron piece, because this is insulating copper wire. It is insulated with certain coating, or maybe covered with plastic. Current doesn't flow through this iron piece. It goes around the iron piece. But this iron piece gains magnetism, and this magnetism is temporary magnetism, and this way a piece of iron placed inside a current carrying solenoid becomes magnet, and this magnet is called electromagnet. Now, one question may come in examination. Let's say in this case, this end of the iron piece or electromagnet becomes north pole, or this end. It can be seen, it can be declared this way. Look at this. If we see this solenoid from this side, then what happens? If you think about this iron piece, the current is passing up this way and goes back and comes again up. It means if it is seen from this side, then the solenoid looks like this. I'm writing a little stylish N. Actually, current is passing this way and going back and coming from front side and going back this way. Yeah. And if it is turned towards you, then what happens? This is anti-clockwise direction. And current is passing in anti-clockwise direction. That's why north pole creates at this end. But at this end, look at this. When current goes back like this, current goes back like this and comes down this way. And if we turn this in towards us, then what can we see? Current is going like this and coming by this. This is clockwise direction. That's why here we have clockwise direction, and I'm writing a little stylish S. Look at this. It means, how can we declare the pole of electromagnet? If the direction of flow of current at the end of the solenoid is anti-clockwise like this, then north pole produces at that end. And if the direction of flow of current at the end of the solenoid is clockwise, then south pole produces at that end. This way we can declare the magnetic poles of electromagnet also. Remember this is temporary magnet. It is made by using electricity, and in the sense of construction, actually it is a piece of iron or nickel or cobalt, any ferromagnetic substance placed inside current carrying solenoid, and we can declare its magnetic pole with the help of direction of current at the end of the solenoid. Okay, this much for today.